This presentation is one of the CR391 installation presentations. It covers the basic installations for a CR391, the basic principles, and how to connect and install for the basic access control functions. It refers to a demonstration of how to hang the CR391. Other installation presentations available are how to connect for the default settings of a CR391. Do a factory default, how to connect for that. Then there are advanced installation presentations, how to add more I/O, more inputs, outputs, and readers to a CR391, and also a presentation of additional functions and features, how to install and how to set that up. This slide shows the pamphlet of the CR391 Universal Controller, listing all the functions and all the specifications of the controller. This document and more presentations are available on the Softcon website. The CR391 controller can execute multiple applications. We are now just focusing on the simple basic access control application. Whilst the controller can have up to 5 serial ports with various interfaces, for access control you'd probably be using 2 RS485 connections and maybe additional one for testing. For the first controller you do need the Ethernet TCP/IP interface. Thereafter you could have controllers sitting on the RS485 LAN. Whilst the controller can have up to 16 inputs, for basic access control you might only be using anything up to 6, 1 or 2 for exit request. That's a push button to request exit at the portal. You could have 1 or 2 sensors on the portal to see door opening. You could have a tamper, and you could have card capture. On the basic access control we enable 2 readers. Yes, this can be expanded to 8, which that is explained in the advanced presentations. So 2 readers requires 4 digital inputs and 6 outputs for LEDs. Also outputs, you would have 1 to 3 outputs, that is for 1 or 2 portal locks and possibly a capture. The housing is ABS flame retard molded housing, meaning it won't burn. Yes, of course it'll melt, and there are your sizes. LEDs on the lid show the status of the controller, that it's running, and communication statuses. There is a tamper detect on the lid, which is connected to input 16, so when you open the lid, input 16 is activated. You can remove the lid using key 45. All Softcon controllers use key 45. Integrated in the housing is a 12 volt 3 amp battery backup supply, optionally 4.5 amps. Please contact Softcon for this variation. The on-off switch cuts the mains to the power supply and also the 12 volts to the PC board. The 7 amp space for the 7 amp hour battery, we do suggest to use gel. Cables enter the controller via a slide tie. This is registered, trademark registered to Softcon. It is a slide that you pull out. You stick the cables through a cable tie. When you're all done, tighten the cable tie and break off the bottom edges of this slide tie so that it all snugly fits. The lid pushes down and holds them right down. There are earthing terminals available for connecting your screen cables, and yes, there you can also see the mounting eyelets. Provided inside the housing delivered is a template showing you exactly where to drill to mount the controller housing. There are eyelets allowing you to mount vertically or horizontally. Horizontal is the preferred method. Mounting plugs and screws are provided with the controller. A video clip shows you how to install the housing, how to hang it. So start off getting a level line, tape this template to that line, allowing at least 10 millimeters on the sides as the housing is slightly tapered. Allow 25 millimeters on the top for you to remove the lid. Yes, just simply swing it open and lift it out. and you need 30 millimeters on the side space for the lid to open. Then drill the holes. We provide 6 millimeter plugs, so 6 millimeter hole and 30 millimeter deep, and drill on the crosshairs in the eyelet where the screws are going to finish. Note the critical dimension of 22.5 centimeters between these eyelets. Tap in the wall plugs, screw in the screws, leaving about 5 millimeter of the screw head to the wall to allow sliding in the housing. Slide the housing over these screws, right hand side first, as you can see under the board, and then left hand second. Before we show the video clip of how to install, let's recap what we are going to do. First of all, mount the housing as per the previous slide. Remove the lid, key 45. Remove the power supply cover by pulling the middle clip slightly down and sliding this cover out. This cover is to protect you from the high voltage. Pull out the top slide tie. Thread through the mains cable through that top slide tie, and you require to use 3 core flex, at least a 0.5 millimeter squared, to give us 700 watt, which is ample. Connect to the connector block provided. This is not seated. When we ship it, it is not seated onto its pins, easing your connection to this. And when you're done, you reseat this onto the posts. Switch the power on and see that the PC board is running before you proceed further. Remove the bottom slide and thread through all the I/O cables. The portal exit device, the portal sensor, the latches, and here use 2 core flex or ripcord of 0.5 millimeters. Also the reader cables. The reader cables must be screened. And yes, connect from the right. So start off with your outputs, your readers, and then your sensors. If there are too many cables, feed some of them through the middle slide tie. Connect all the cables to the PC board terminals and route them around the PC board, not over it. We'll show the terminal connection shortly. Remove the middle slide tie and thread through your Ethernet and or LAN cables and all the serial cables. LAN cables must be screened. Remove the PC board by undoing the 2 screws on the left. Just simply let the PC board hang out of harm's way. It's all connected, so just let it hang. Cut back the cable sheaths and connect the screens to the provided earth terminal connections. LAN segments, only earth on the one side. I'll get to that shortly. Clip in the battery and connect the positive and negative terminals accordingly. These cables should be routed above the clip that holds the battery in place, under the power supply cover. Replace the power supply cover. Then replace the PC board. Clip in the right hand side and screw the left 2 screws in through the eyelets that are provided. These earth eyelets protect the board from noise and reduce lightning damage. Switch on and replace the lid and test your installation. Once all is correct, tighten the cable ties and clip off the excess of the cable tie. Then your slide, break off or cut out or file off the bottom from the bottom so that these snugly fit over the cables. Please note that the top of the slide must not impede the lid from closing completely, so remove enough from the bottom. When you do not use the 7.5 amp hour battery, a 4.5 amp hour battery can be used, and then the CR394 PC board, that's the board with 32 inputs and 16 outputs, can be mounted below the CR391 PC board. If you do this, first connect the lower board. Do all the CR394 connections before you install the top PC board. Before continuing with this presentation, you should go and watch a video on how to mount the CR391 controller. It is not part of this presentation and can be viewed as a separate video, and it is all available on YouTube. There are a variety of videos available on the Softcon website or on YouTube. The simplest is go to YouTube so you don't have to download it. You can search for this reference or simply go and search in YouTube, go and search for Softcon BMSS, Building Management and Security Systems, and find the Softcon logo. This is a directory of Softcon videos. There are a variety of videos. The one section is all why videos, why to do something. It's more aimed at marketing, why to update, why to use. And then there are a variety of how videos that show you how to install, how to, etc. This presentation is also available on YouTube. There's a video, for example, on how to connect for the default and how to connect for the default. So before you get in the ladder, watch this video. It shows you in detail again on how to connect it. And then there is the video on how to hang, how to mount the controller. To repeat what we said in the video, please use blue cable. We strongly suggest this so that they can stand out. So Softcon blue, and we have them, these cables in blue for all the cables required. As shown in the video, a lid insert shows all the connections to the CR391 controller. Also all the links, what they are for, and where everything is positioned. More details later. On this lid, there is a section that you can fill out that will help you when you go and commission your system, your site. We do suggest fill this in, take a photo, and leave this inside the housing. So let's look at the terminals in detail. On the board, there are 7 identical plugs, all have the same 10 terminal connector. Each terminal has its unique number 1 to 70, that is shown on all the connection lists. Also, on the PC board are etched abbreviations for each terminal. Inputs. These 2 plugs are identical. On the left, you have plug 1 is inputs 1 to 8, plug 2 is 9 to 16. Inputs all have 5 volt pull-ups, so you simply connect potential free contacts like a push button or a door sensor, or you can connect open collector outputs to our inputs. When you reset the controller, it goes to basic factory defaults, and the inputs are configured by default then as shown, where for 2 doors you have egress, that is push to exit request, action complete, that is the portal sensor. So for reader 1 and reader 2 as shown, ground terminals are provided for the return line. Note, input 16 is the tamper on the housing. We can supervise your inputs by simply connecting resistors at the sensor itself. Then we are supervised, we are monitoring end of line, so we can detect short circuit and open circuit. So yes, for a small little installation cost, you have dramatically better security of your installation. The reader supplies, these two plugs are identical for reader 1 and reader 2. The reader supply is 12 volts, generally via 90 ohm current limiting resistors on the board. You can short this by putting in the plugs L1 and L2 to short this out. These current limiting resistors there are to prevent short circuit at the reader from blowing the fuse on the board. So tamper, to help with tamper. The data lines, the high-low or data clock, have 5 volt pull-ups. So readers have open collector, as they all do. LEDs are open collector with 2K2 serial resistors limiting the current to the LEDs as required by most readers. PC boards of later versions have links over these resistors so that we can use these as simple open collector outputs. The relays, there are 4 relays. They're 3 amp, and there are 2 normally open and 2 are normally closed. Yes, you can change the polarity by settings. It might be that sometimes you do want to use the normal or normally open or normally closed as on the board, so as to prevent switching up to getting a pulse on the relay. These are potential free relays, so you feed through your 12 volts, or you could switch AC. The power supply, 12 volts in from the power supply, and the outputs, they are via a fuse, via 2 amp fuse. We provide many terminals so that you can connect devices such as passives and other devices. Communication. On plug 7 we have LAN, RS485 LAN that you would use for your multi-drop LAN or sub-LAN cables. There are also 2 RS232 options that you would be using for tests and for certain serial readers. There is one of those terminals on newer versions. You can stick a link in and have a 5 volt as required by certain readers. If not, you'll have to short out a resistor on the board. Ethernet, it's the standard RJ45 connector on the board, and this is not included in the CR391 the bare bones version. So back to our basic access control installation. This diagram is on the packaging, showing you the basic connections. Also, it is also provided as a pamphlet inside the housing. Here we see the inputs, the standard inputs, the default. They, as I said, have 5 volt pull-ups, and we have the portal exit device. So that's the new name for egress, or the push button. The portal sensor, so action complete to see if the door's opened illegally, open too long. Reader enable, optional reader enable, so the reader will only be enabled if that input is high. And you might install a capture unit as shown here. We've shown you the basic connections. That's to sense when a card is dropped in the capture unit. Readers, the Vigan or data clock readers, and yes, you have to use the screen cable. And if your reader is mounted on a metal like a gooseneck, that gooseneck must be earthed. If there isn't an earth there, use the screen cable that is earthed on the controller side. Outputs. These are potential free outputs. Again, we say 0.5 millimeter squared cable, not that thin ripcord. You are going to pick up problems. And yes, you have to feed the power through the relay as required. Generally, the portal locks are 12 volts. There's also shown here is the capture, the relay to open the capture unit. Now, inductive loads such as locks and relays, when we are switching them, there is a flyback. So we provide 12 volts, and when you open that relay, it throws back a high voltage at you that causes a spark, deteriorating your relay and making noise in the box. The answer is simple. You put on DC, you simply put a flyback diode, as shown here. We do provide this with a controller. So the cathode to the 12 volts, so that's the edge with a little line, so connect as I'm showing here. For AC loads, there isn't a polarity. There we use a cap resistor. Details in the documentation. There is no polarity. These we also provide for 2 latches. Before we continue, let's do some education on RS485. RS485 is half duplex. It means only one can talk at a time. Everybody listens, one talk. And yes, you form a multi-drop LAN, so multiple units, controllers, devices on RS485 LAN. It is differential. So the data and not data, there's a difference of 0 volts or 5 volts, and these two flip around. And we look at the difference between the two. So if there's noise, both move up and down, and we're only looking at the difference between these. And yes, we do use a screen cable. And because it's differential, we can go 2,000 meters of cable. So you need two pairs, two twisted pairs. As I said, the data not data are twisted together, so if there's noise, they both move together, hence twisted pair. The other pair we use for ground. This is to get the potential of all these devices at the same. Otherwise, my 5 volts is not the same as your 5 volts, and we could damage something in the board. Hence, we send ground together to get them all at the same reference. It's multi-drop. That means no T's. We go from one node to another node to another node. No T's. There are only two cable ends. So you go from node W to X and from X to Y, and only two ends to this cable. Screen. We must screen this cable to keep noise out, but only screen at one side. There might be that earth is not the same at 2 points, and we don't want current flowing because there's a potential in earth. So do not loop through. Here I've now shown we earth at node W, we earth at node X and node Y, but not at node Z also. So each of those segments, one earth. So not loop through. The RS485, data not data, are normally floating, so everybody listens and only one transmits at a time. So we need to separate, we need to pull these cables up and down, the data up to 5 volts and not data down. Otherwise they would float and they might then pass cross one another, and then we are going to see data which is incorrect. Now on most PC boards there are links to pull up and pull down, and yes, you must only do this at one point, otherwise the load is too high, and preferably in the middle of the cable. Generally one does this at the master. The master doesn't have to be at the middle, it could be sitting anywhere, so we will show the links shortly. The two ends of the cable must be terminated by the characteristic impedance of the cable. The cable that normally is used is 120 ohms, so you need to stick 120 ohms between data and not data, and screw them into the terminal so that if you do remove the PC board, that the resistor is still in the connector itself. As I said, all nodes listen. They're all in receive mode, or only one transmits at a time. So it's polled. The master says, hey, number one, have you got data? Number one says, no, I don't, or yes, data. Number two, if you got something to say, so the master polls and the nodes answer. So that was RS485. So what is RS232? This is between two units only, as opposed to RS485 could have multiple units on the same cable. RS232 is full duplex between two units. And the voltage levels are plus and minus 12 volts. TX to ground, RX to ground. And maximum length is only 3 meters. So it's between controller and a device like a scanner, a printer, a reader, a modem, etc. So TX to RX and RX from TX. TX normally sits at minus 12. That's when there's no data, so the data is high. Or it goes up to 12 volts when there's a zero. RX floats, so that's an input. There is no voltage on it. So here you could easily check if your cable is correct. Measure between the TX and ground, you should be getting minus 12 normally. On the RX line, you're not going to measure anything. And yes, if you do connect them up the wrong way around, nothing's going to break. Obviously, you're not going to have communication. There are optional handshake signals, like a request to send, clear to send. We do not use this. Okay, so now we know RS485, RS232. Let's see what we have available on CR391. The CR391 has 5 serial ports. It can have 5 serial ports, and we've named them A to E just for document purposes. It's 1 to 5, but let's call them A to E. And on the board there are 12 serial interface options. RS485 is an interface. RS232 is an interface. So selections of those 5 to those 12 are via 3 identical links. And as you can see on the top right there, I have there's COM A goes to can have a link to an adjacent pin. So this is how it works. There are 4 RS485 options on this board. So there they are on those matrices. There are 2232s, and then there are Wi-Fi, GSM, and Zigbee options, and 2 modules. You can take 2 piggyback modules. So don't worry about this. This is advanced stuff. Just know there are interfaces available on our board. So how is the CR391 shipped as default? Default COM-A is linked through to the RS485 handheld connector, and the default is FLAN master, so ready to be a handheld. COM-B is RS485 LAN, so that's on the LAN connector, and LAN slave. So if you were a master, you would have to come and change this to LAN master. C is linked through to RS2321, and the default is test, so to do tests, built-in byte, things like that. COM-D is linked through to RS4851. There is no type default setting there. The same goes for E. It is linked through to TTL, the TTL connector, as used by the medium, built on the medium board, and no interface is set. Let's have a look at the links on the board. Link E1 and E2 are for RS4851. It gives you the pull up and pull down, and also end of line resistor if you stick these links in. So yes, remember RS485 LAN, you need to pull up and pull down somewhere on the LAN, and if this were the end, you need to have your termination resistor in. So if P3 is in, we have 120 ohm resistor. Same goes for link E3 and E4 for RS485-2. For P7, where we normally put our LAN master or LAN slave, we actually have 2 RS485 buses. One for a request to send 485 LAN. This is used for specific type of installations where we have to interface to another kind of unit, like a fiber interface unit. So there are pull-ups and pull-downs for the request to send line and for the data line. Note, no 120 ohm resistor links, so you have to put your link for data not data on the terminal itself. Just for completeness, all these links are for Wi-Fi, for setting up and doing Wi-Fi. Don't worry about that now. The handheld link, when P4, this is for connector P14. When you stick the handheld link in, then that RS485 only communicates with node 1. That's for when you're using the handheld to test and to do setup. And there is a link 11 to give you end of line. Normally we would be an end of line. Note, there are no pull up and pull down. They are on the board already, so there is no link for it. So we are mastered to that LAN. There are pull ups already. E6 is a test link. It works in 2 ways. If you power up with this test link in, the communication settings default for production tests. That is, COM-A reverts to FLAN master for handheld, COM-C for RS232 tests, so that we can test the board, do the byte tests, and the IP changes to as set. So do not power up with this link in. These settings will change to these values. If you change the link, you stick it in when the board is running. So the board is sticking, and you then insert this link. 2 PC boards, LEDs on the PC board. Reader 1 and reader 2 go on, and after a second or two, reader 2 LED goes off. If you withdraw the link, then the board resets back to factory default. As shown previously, there are 10 LEDs on the board. And yes, there are the colors and the description of each. The top one ticks every second to show the board's alive, that the program is running. Comms LED, a red LED, if it's on steady, that means we have comms up to whoever is above us. Reader 1 and reader 2 are for odd numbered readers or even numbered readers. So yes, reader 1 would be yellow, reader 3 would be yellow, reader 2 and 4, etc. would be green. There is a diagnostic LED that we can set certain functions to switch this LED on when communicating. This is more for testing. Then we have an RX and a TX setting. What LEDs, what communication must we put on this? So we could say, for example, on these LEDs, I want to see COM-C, RX and TX. So this, there is a setting, and to match which COM 1 to 5 I want to see on these LEDs. If the setting is set to 0, it will show COM-A or COM-B activities. The other three are for these specialized modules, GSM, Wi-Fi, and Zigbee, when they are functioning. Now for a simple system. Let's connect a controller to a PC. Yes, via Ethernet, a TCP connection. There are future options of GSM and Wi-Fi. So the program on the top, example Softcon 3, communicates via this TCP connection to the controller, sending down setup and changing control. It receives back, events are reported back to the PC. And here I'm showing a biometric reader. How it works is the PC sends templates into this reader, and when you put on your finger, it's found in the local database. It reports out Vigant to the controller. The controller then grants or denies access. Here I'm just showing a card reader, data clock, or Vigant reader. You badge your card, data to the controller, controller grants or denies access. Let's add another controller, also TCP. And yes, it's a new TCP connection, so it is also node 1. Node 1 is a TCP controller. Here I'm showing two biometric readers connected. Now, let's create a subLAN. I'm adding a controller via RS485 sitting below this node 1. Yes, the node 1 is the master to the subLAN, and node 2 is a LAN slave. So how it works here is the PC sends setup to node 2 via node 1. It just reroutes it to node 2. Same events at node 2 are sent to the PC via node 1. So it reroutes these events. And there I'm just showing you reader options, any option, and another node on this RS485 LAN. And yes, I can have up to 128 controllers on this LAN. Just showing two readers on that LAN. We can have a front LAN on a controller. It's expanding the I/O to this controller. You saw a handheld is also sitting on this front LAN. So if you needed a keypad, for example, or a display at that controller, you would connect them on this front LAN. So the controller is the front LAN master, and these units below are the front LAN slaves. And yes, it can take a reader, and it can take inputs and outputs. This is explained more on the advanced presentations. So when to use 485 and when to use TCP. What's the advantages? Well, TCP, there is more cable. You need hubs or switches. There is more data flow, TCP data flow. So because the PC must poll these controllers, and there's a keep alive signals going backwards and forwards. The advantages are normally this is the infrastructure provided by the IT department. So normally they carry the costs. But yeah, the IT department sometimes can be a bit of a pain. It is faster to upgrade firmware. Yes, we can upgrade controllers firmware from the PC via this TCP connection, and it is faster than
upgrading a controller down on the RS485. Also, setup is faster to a controller, but then again, you're only doing that probably once. Less lightning damage, probably yes, because TCP, these Ethernet connections are via little transformers, so it's normally, lightning damage is normally less. The advantage of RS485 LAN, definitely less cable, and there are no hubs or switches, so cost is lower. The installation is similar. It all depends on where the cables, how far apart are these controllers. There's less data flow in the online data. So the node 1 is phoning node 2, keeping them alive, so there is definitely less communication on the blue on the TCP lines. It is slower to do firmware upgrades, and setup from the PC is slower. But there again, it hardly ever gets done. So, when to use what? To use TCP, if the reader is, you don't have a choice. You've got to use the TCP connections. You must have a LAN master. The LAN master must be TCP. You don't have an option. Then it depends on the infrastructure. For example, if you have network in different buildings and the infrastructure, the TCP infrastructure is between these buildings already, you will definitely then rather use the TCP infrastructure. When to use RS485? Well, it depends on the infrastructure. If there are many controllers right next to one another, then go RS485. Yes, the one of them is the LAN master. He's TCP to the PC, but all the others, it's a simple cable just between from the one to the other one. Very simple. It's all about cost to decide what to use when. And yes, the controllers that don't have the TCP, in other words, the bare bones, they don't have those ICs on, those components on, are lower cost. Installation done. Now, how do we do the setup? How do we set how this controller works? The first way is the online PC program, typically Softwin 3. And this is the primary TCP socket. It links to the controller, and yes, you can from there do a controller detect. It will show you all Softcon controllers. It detects on TCP, and you can see the MAC address and the node address and change these. It is the operational setup. So the settings on this PC, if you reset the controller from the top, this is with these settings, this is how the controller will do it. It overwrites any settings that are in the controller. Another way to do setup and see setup is with a program called SES controller. This is a second socket, so it's also a TCP connection. It's a second socket, and yes, it has controller detect as the Softwin 3. You can read back the settings in the controller, so great to see what is in the controller. You can make temporary changes and do separate setup changes, but yes, this will be overridden by the operational setup by Softwin 3. And yes, here you can set up from file. We have files. If you're busy doing an installation, you can read in, for example, a setup with booth control or a man-trap control, or read in these settings, program the controller, and carry on with your installation. So this door will be functional. Another way is with a hand program. This is a handheld device that you simply plug in at the controller, and it's a 485 interface. So you plug this in, and you can there and then see what is in the controller, change some settings. Again, it's temporary. It will be overwritten by the PC, the operational setup. And it also has additional tests, like show me the card that you're reading, how many bits, enable test the LAN, some extra controlling and debugging features that you can do with this handheld. Let's look at the handheld option. Yes, you probably might never use it, but it does make life easier. When you add a controller, simply plug it in, look at settings, make changes, and there's some additional tests you can do. So you simply plug it in P14, and yes, it requires that COM-A is set to RS485 via the links, RS485 Handheld, and you need A to B FLAN master, 19K 29 bits, and you need the pull up and pull down and termination links as discussed previously. You need to put in the Handheld link. This enables that front LAN to do Handheld. In other words, node 1 becomes Handheld. There is a booklet that we ship with the controller that gives you complete list of every setting that is available via the Handheld. It shows all the settings in the controller. So this is what the CR395 or the older model C94 looked like. It has a display and a keyboard. On the display, it's a 2x20 line display or 2x16. It shows you the little question mark there is the mode that the controller is in. There you would be seeing a U for universal. It's the version number and the node address of the controller. The certain keys have a function key. So if you push that F key, the star, you hold in star and you push 2. It then becomes move cursor left command. Same for shift or star 3, cursor moves right. Cursor moves down for star 5, so you hold in star, you push 5, cursor will move down. And star 6 moves cursor up. Cursor will scroll. So if you push star 8, if the data is ASCII data, for example, it's the controller's name. So if you push star 8, you will scroll through ASCII down. Star 9 will scroll through down. It's if you had to go and write something. We normally have digit keys, so this gives you all the alphanumeric keys. On certain options that you will see on the display, the cursor could change to a caret. That's that little upside down little arrow pointing upwards. Now if you are on one of those characters on display, for example, you would have that for input type. You would just push then key 2 or key 3 and it will scroll through the options for this selection. For example, I'm showing here the pulse timeout. I'm showing you a little caret there, 10 milliseconds. Now if the cursor was on that and you just kept on pushing the little up key 2 or key 3, it would scroll through to seconds, minutes, etc. All those settings, those definitions on the bottom of the housing. So if you forget that, just turn around. What those shift keys are for, those function keys are on the bottom of the box. So let's look at just a typical example. There are menus. There's a row of top menus showing move to menu, and because there's a greater or a less than sign, if you now pushed cursor left or right, in other words, star, holding star, push 3, or holding star, push 3, we would move left or right. So there I've pushed star 3, so I've moved right. It shows me a new menu. Now there are data under these menus. So I'm walking around the top through the menus, and when I then push star 5, I will go down. There I've gone down. I've pushed star 5. I've gone down. Now it shows me I was in database edit, and there I'm seeing card reference 1. I'm showing enabled, so I can now edit there. Where my cursor is, if I type just over that. And now again, if I push star 2, I'd be moving my cursor left. It would wrap around to another screen, if there was a screen left or right on this level of the menu. If I push up, I would be going back up the menu. Down, I said star 5 is down, but if I am in this submenu and I just push the hash key, it's the same. So simpler, I don't have to hold down the star key, I just push hash, it will move down, 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 down. If I push the star key, it would move me up to that top menu and actually move up the menu and one right. It also does, if I push it again, it does a save of all the setups that I have changed. it saves it back into the non-volatile battery backed up memory. So there I'm going down, and note the cursor will move along where it should be. I just type an overwrite. So up or down. Okay, let's say we've hit the star and we've moved up. Let's go and look at setup. I'm moving down setup, so I've pushed star 5. I'm going down. It shows me the COM setup, and yes, here are different menus on the top again. I can go left, right. Note the less than or the greater than. So I'm moving left, right on more options on setup. I've moved from comms to inputs. Let's go down. I push star 5, or I push hash, and I go down. There it shows me input setup. Note on the top right, it's telling me I'm editing, I'm setting input number 1. And there is the name of the input. Now, that could be any name. It comes from, all these settings come from the PC, but I could change it here. Now, if I'm on an ASCII alphanumeric character, if I now pushed, I said it was star 8 or star 9, that would scroll up. It will go from, scroll through the alphabet. I could at any time just push a number, and then obviously that number would be inserted where my cursor is. When I edit something, and the cursor automatically moves one right. I've gone down into a new setting of this input. If I now went left, where my cursor is now, my cursor is totally on position number 1. If I went left, I would go to input number 2. If I moved right, and I moved right to the end, and there's no more data, it would move to the last input. So I move the cursor, I type, and yes, going left or right out of these menus where there is a reference number on the top right. If I move left or right, it moves to the next or the previous reference of that, for example, input or output or reader. I've moved down again, and here I see this is the input type. This type is egress. Yes, I will explain more detail of what the other means. But note, my cursor now is on one of these claret, one of these little upside down pointing up. I'm on a claret. Now, if I pushed, as I said, 2 or 3, it would move to the next or previous option that I could have as an input type. Now, input type would go from egress to intrusion to action complete or whatever is next on the list. As I have explained, you probably won't ever use a handheld, but for completeness, I'm going to go through the settings on the handheld. You might be using it to ease your life at the controller, do settings. This display here is on the menu on the LCD for resources. This shows you how many readers we are using. We can have a maximum of 8. This controller, the firmware in it allows 8. That's the maximum. Then there's a key setting. That second digit is the key set. This key allows me to have a maximum of 2. So yes, readers, inputs, outputs, and certain functions are controlled by license keys that you purchase from Softcon to increase the number of these resources. So I can change a setting. How many am I using? If I set less, then it does speed up. For example, if I could have 128 outputs and I'm only using 5, set it to 5. It makes responses just slightly faster, and especially editing with a handheld much faster. There are other settings of how many cards, how many inputs, outputs, how many time groups, and how many time zones. Yes, in basic mode, you won't ever change this. For example, you could say, I need more time zones or time groups. Call Softcon, and they'll give you a key. Applications. Now, some applications use readers. For example, access control uses readers and vending uses readers. If you are using multiple applications at the same time, you need to go and set which reader is used by which application. Now here I've said there are 2 access control readers, and they're using reader 1 and reader 2. More details in the advanced presentations. Now let's look at the communication setups. The controller name, yes, this is sent from the PC. Everything is sent from the PC. I can edit this name here locally. This is typically used when I'm sending SMSs to identification where the SMS came from. The node address is something that you will edit, and yes, the controller detect on Softwin 3 and on SES controller, you can change these values from the top. So node address must be 1 or more. This is the mode the controller is running in. There are legacy modes that it runs in. You'll be using 7 for universal. Now note this value of 7. If you look at all those digits that I have there, 4, 5, C, 4, if I select 0, it will be selecting CR 3, 5, 4, etc. I'll explain more later. You will be setting 7 for universal. So it'll be 0, 1, 2, 3, 4. You are sitting at number 7. How do I communicate with a PC? I have options of serial, IP, modem, and USB. If I set 0, it's serial. If I set 1, it's IP. If I set 2, it's modem. So the default is, if it's a CR391B, it does not detect the Ethernet IC, so the default is 0. So it'll be serial. I have to communicate as a LAN slave. If it detects Ethernet, the components, the default will be 1. Then I'll be IP upwards to the PC. If I'm using IP, in other words, if the previous setting was 1, this line will appear. I set, here is the IP address. And again, this can be changed by Softwin 3 or by SES controller. Or I can change it here with a Handheld. And the mask and the port number. Now for the serial ports. Note on the top right little window, you will see SA. So I am now seeing the settings for COM port A, serial A, and it's saying it's FLAN master, and there again the little cladded sign. If I push 2 or 3, I'd be scrolling up through the types. So serial A here is FLAN master, so that's for my Handheld. And there are other settings for serial A. There's baud rate, data bits, parity. Now here again, if I went left or right, I would go to COM A, B, C, D, E, and scroll around back to COM A. If the COM that I have selected is, let's for example say I was on COM C and I moved down, I would get this line if the type of COM C was one of the reader types. So if I'm saying that this COM port is a reader type, I need to say, well, which reader is this? So I can say COM C is reader number 1, for example, or reader 2. So that'll be the first digit. I'm linking the serial port to become a reader. The second digit there, if I put a number there, if I put a 1 there, it enables that this data coming from this reader is also sent as a card event. So if the data coming, I badge a card, the data coming in from that serial reader gets appended to that entered, that command. So the serial data is linked to the card entered, the card badged. But if the second digit is set to 1, I also take that number that came out of that serial port. For example, it could be your weight, it could be an asset that you, I flip it around and I also create an event and saying, well, that number is actually also a card and the event, and then I link it the other way around. Okay, more detail of this in the advance. So don't worry about this, just know that you can link data coming from serial readers, link them to cards, and make a new event as if that was a card being badged. Yes, I can. If the second digit is a 0, I then know that it's a card reader. It also depends on the type I set. Serial ports. We have 2 LEDs that I can select which COM port do I want to see on this LEDs. It helps for debugging. So I select which port. If there's date activity on that COM port, switch on those, flicker those LEDs so I can see there's communication coming from that selected serial port. Here is a test option. If I do have a COM port that is set up for test, I can say a serial data, echo it to this test port. For example, if I was communicating on GSM, I want to echo all the commands just for test onto this test port. I would be sitting here and saying, okay, COM D, I want to echo to the port that is set as test. The second digit there is, it's saying that the data that I am echoing actually is hex data. So convert it so that I can see display. If I'm LAN master, this display tells me how many slaves, what is the largest node number under me. So if I am LAN master, I will have to come and say how many slaves here. There again, the setting comes from the top, so don't worry about it. In legacy mode CR395, the handheld, there is, if it is older handhelds that haven't been upgraded, we can communicate on legacy mode. There are limitations, but then I would say, which nodes do I have on that front LAN? Now, this normally, you upgrade your handheld to the latest, you wouldn't see this. Here I'm saying, how many nodes do I have? What's the largest node number I have on a front LAN? If I had just one, obviously one, I could have a couple of these displays or keypads or expander units on there. Again, this is advanced stuff. Don't worry about it. None of these settings, except the ones in the turquoise, the teal color, that you might come and change. The others are not used in the basic modes. This option says keep the stack, the event stack, keep it in battery backup, or I don't want any events to be reported to the top, or don't, if I power up, lose them. Don't put them in battery backup. This option, if I do have a selection for GSM, I am saying what kind of modem is connected to me. So 0 would be, it's an M95, that's the onboard module. If I selected option number 1, it would be the Siemens MC35 modem. So this line you'll only see if you have a COM port set for GSM. If I have GSM, I must say, well, what do I want to have on this GSM? Now, there are a couple of modes, a couple of settings I could have here. There is, if I put a 1 in each column there, it will enable, and it enables it in the order of audio. This option is not available yet. There's data. This is not available yet. SMS. So if I put the third digit to a 1, it will send SMSs. That this modem is enabled to send SMSs. The next one is clip. That is when somebody calls this modem, the cell, it's actually a cell, calls us. We look at the caller identification. If we find it in the database and it's enabled, we will open the door. There's also a pass-through option selection. This is simply for tests that's used by the engineers. More handheld settings. The local controller has a database of up to 125,000 cards. I must say what kind of cards we are using. We are either running numbers or random numbers. Now there again, this is all set from the top. I can block a certain bottom section of the local database that the PC cannot override. This is used in certain applications on things like server rooms where they don't want the PC to override certain cards in the controller. So they would be sitting right in the bottom of this database. There are other settings defining what the local database looks like, whether it's got a pin, whether we are doing random checks, where we have extra property settings. Don't worry about this. This is all advanced settings, not used at all in the basic modes. Let's look at reader settings. Now here again, we can have, remember, up to 8 readers. So when I go down, I will see reader name. It's the name of the reader and could be anything, example, front or in. And it's showing me on the top right, it's reader 1. So yes, I could go left or right to reader 2, 3, etc. Then, where is this reader connected to? Here again, don't worry about this. All the defaults are fine. You don't have to touch any of this stuff. It is telling me it is which COM port. 0 means it's onboard. This reader is not connected serially to me. It's one of the 2 onboard readers. The second setting there is which node on that serial line, and then which port on. So the setting here is for local reader 1. If I have multiple readers and I want to link them together, example for anti-passback, anti-timeback, or for man-trap, I must say which ones are connected together. Now in the basic simple mode, obviously the 2 readers are connected to one another. I can invert the clock signal of a reader. For example, on mag readers, you might want to invert the clock signal. Again, these are very particular for certain readers. Don't worry about this. I can say, my reader, how many LEDs he's got. Most of them have 3 or 2 LEDs. When it's 3, it's the traditional colors of red, yellow, green. So either 3 or 2. If I select 2, we actually create a yellow out of red and green. I can also set that yellow must flash. So if I set 0, that means 3 LEDs. If I set option 1, it's 3 flash, so yellow will flash. If I set 0, 1, 2, if I set 2, it's 2 LEDs. If I set 3, 0, 1, 2, 3, it's 2F, which means 2 LEDs flash yellow. If I do have an LCD, for example, I have a CR391 and I have an LCD and I want to display messages on, for reader 1, I'm busy with reader 1 here now, I want to display on which LCD. It does happen that you might want reader 1 and 2's information to be displayed on LCD 1, for example. If I have a 1 set here, it's enabled for card display. So if I badge my card on that LCD display, you'll see the card number. Messages from the PC. I could have messages from the PC. For example, it'll show me my clock in and clock out times. I can say how long must this message be displayed. Again, these are all advanced settings. Don't worry about it. It's there for the future. On certain of the older versions of CR391, we set readers as no voltage, 5 volts or 12 volts. The new readers, the new controllers are only 12 volts. The card type. We have numerous kinds of Vegan, data clock, serial, numerous kinds. There's a whole list of these. They are, if I set anything from 0 to 6 or 20 to 58, those are all the different Vegan options. Data clock are settings 8 to 16, and then there's a variety of serial options. So how do I convert numbers into the number that are required? Serial settings are from 60 to 76. Please contact Softcon or go through the controller manual. Then we have site and client code. Certain of the card formats have a fixed section in the card that is fixed for this site. In other words, for example, I could say the first 4 digits on this site are 1, 2, 3, 4. All cards start with 1, 2, 3, 4. So when I badge my card, I will then go and see, the client and the site code match. Therefore, I look further. If they don't match, then it is illegal for this site. So if it's 0, if these values are 0, site and client is ignored, even if there is a site and client on the card. And yes, the card type knows where this data sits. This setting is generally for ISO mag cards. It tells me where are the number and where are the facility location. Where do these numbers sit on the card? There again, when purchasing cards from Softcon, they will tell you what setting to do here. And again, all these settings are done on the top, so don't worry about it. There is an alt setting. If the site and client doesn't match, then we could use a different card number. This is used on sites where they have multiple cards. For example, certain of the casino staff and patrons use the same readers, so we can say, well, if the site and client does match, so it's not a staff member, then use card number sitting somewhere else on the card. This setting can be used to force, say, there's only so many digits in certain modes, in certain card types, how many digits are we going to use for card number and how many are we going to use for facility code. In certain card types, especially in running card numbers, we can say, but deduct the certain number from a card. For example, you have one site that have numbers 1 to 1,000. Another site has, I'm using the same site in facility code, but that site runs from 10,000 to 20,000. Then I say, go and deduct 10,000, so it brings me back to card number 1. Parity, a lot of the formats have parity in their card structure. I can say ignore it. We do find that people manufacture cards and then they forget to switch on the parities, and then we have a problem. So we can switch it off. It makes it slightly more prone to errors, but it's so it hardly ever happens. The setting is I want to match the number of bits exactly to this setting. For example, I have 44 bits. If I say only read 44-bit cards, then I would go and put in 44 over here. I could have 44-bit and 32-bit and 26-bit on the same reader at the same time, facilitating the use of all these different cards. This one forces me to say only use a certain number of bits. The duress bit is on certain readers, for example on academia readers, they can have a duress finger. So you put down, you use another finger. It gives me the card number, but then it also gives me more data to tell me that it's a duress finger. And this setting tells me that it is one of those. So they're again very specialized. Contact Softcon if you're using duress fingers. Right, the axis and the tick setups, the second last screen of setups. For access control, again, for each reader, you are setting up for random search. What type of random search are we doing? And what percentage is this reader going to let through? Again, advanced settings. I can click the latch. It's a pulse time. I can enable the reader on an input. For example, you might have a loop and I am enabling the reader and I'm enabling the push button on an input. So again, advanced settings. Booth, this is a man trap. I have different options. I have no man trap, or I have, yes, it's a 2-door man trap. It's a 1-door, it's an interlock, it's a reader inside the booth, a single reader inside the booth, or I can call the booth. These are different booth options. Again, advanced options. Action complete. If I have a sensor, the portal sensor, I can say how long, what must the latch do, the lock. I can say there is no locks, there is no portal sensor, then the latch will be enabled for the time set for the latch. Or I can say enable the latch until the door opens. Or I can say do it for the timeout, or I can say till closed. If we do have an action complete, a portal sensor, we have all the advantages of door open too long, door not open, door opened illegally. Capture. I could have a capture, as we showed in the default connections. I could have a capture unit connected to a reader, and I can say no, there isn't a card capture. If there's a card capture unit and my card is marked as a capture card, I badge my card, access granted, and then I enable the capture unit, and then you drop in the card, and then I will grant you access. So there are capture or not. There is a motorized capture unit. There is, I must capture and disable the card. If expiry is set, I must disable the card. There are a couple of options. Again, these options are advanced. Normally you would have capture or not. Anti-passback reset. If I have an anti-passback reset input, I can say what must I do when I reset. I can say if there is a card number, enable both readers, all the readers. I can say if I'm enabled for any card, then enable the other card. So this is an input. For example, comms was down or something. I push this button and I will enable all cards if it is enabled for either reader, or I can disable them all. Again, advanced settings. Anti-passback. I can say there isn't anti-passback, or I do have anti-passback, or I can have additional settings like if we are offline, then and I'm enabled for either reader, then let me in. I can say disable the card if I go in. So again, advanced settings. So normally simple settings are anti-passbacks enabled or it's disabled. Anti-timeback. That is, this card will not work for a certain time period. Now I can say if I do use the reader, then this reader is just simply going to time out. Or I can say if I do go through this reader, clear the other readers that are timing out the same card. And this is how long is anti-time back set for. For example, I could say badge this card, and this card will not work at this reader for another 2 minutes. Illegal attempts. I can say after 3 badges, then that's illegal. Illegal attempts. For example, on pin pads, you do a setting like that. You don't want to have a guy there with a batch of cards and he's badging until he finds one that's got access. So you can say only so many attempts. And then the reader is disabled for a certain amount of minutes. So if I do have multiple illegal attempts, that reader is disabled. It is disabled for any card until somebody comes through from the other side. This setting is advanced setting. This is, I can locally control other outputs because of an event, because of a reader event. If access is okay, access is granted, or if access is failed, or if random search fails, or if there are multiple illegal events, or there is a duress, I can drive other outputs. There's a whole presentation on this. Timeout between multi-badges. I can say, yes, I need to badge 3 cards before within the timeout, before access is granted. I can also say that the first card must belong to a certain output group. So this card must be first, followed by another 2 cards within a timeout period. Only then will access be granted. Again, advanced settings, all this comes from the top. Don't worry about it. Just know that there are wonderful things you can do with this controller. Okay, some time settings. Here's the time in the controller. This is synchronized by the PC every minute, I think. Every minute, every half an hour. So yes, weekday Monday is 1, Sunday is 7. So I can go and change the time here, but it's automatically synchronized with the PC's time. A very specialized setting for, I can say certain time groups have counting limits. Don't worry about this. Advanced settings. Holidays. I can have up to 30 holidays in the controller. So I'm setting date and month, and that day is a holiday. Here, for example, I've shown Christmas as a holiday. This is holiday number 1, and I might not be enabled for holidays. If I'm landmaster, how long must I, before attempting to poll offline slaves? If I have GSM, these settings are how often must I send an SMS. It sends some statistics every hour, for example, or once a day or once a week. And when must I do it? I must do it at 12 o'clock in the day. You require this if you're using Clip. If you don't send out any SMS or anything, eventually they block that SIM card. Right, we are on the last setups that are in a controller. Firstly, inputs, and yes, from 1 to 128 or whatever your key allows you for. First of all, older controllers had an option, a local option of expanding inputs. The newer controllers use CR394s for expansion. So these are specifically the older controllers. You can say how many expanders are there. So input name, and yes, you can type in anything, example front door. And again, left or right to input 1, input 2, scroll around. Again, similarly as we had for a reader, where is this connected? Okay, here it is showing I'm connected to input number 1 of onboard because my com is 0. Again, explained in advanced presentations. This input, what kind is it? It is an egress push button. Which one? Which reference? So this is egress 1 that I'm showing you. And yes, you can change polarity. The second digit there is polarity. I can invert it. And I can say this is a supervised input. Remember, supervised had the additional 2 resistors at the contact, so I could get open circuit and closed circuit. So yes, for each input, I must say is it supervised or not? Again, here's an advanced setting. I can say this input is only enabled when another input, of linking it to another input. If that bit's enabled, only then am I being monitored. Or I'm only monitored if a certain output is enabled. Now again, advanced settings. The default is 0, so that means always. This is linking, controlling other outputs when this input changes. So I'm saying I can have, if this input becomes active, I want to drive another output. For example, if I do a push button, I can switch on another light, or I can switch off the pool pump. So I'm saying when this input becomes active, I can drive other outputs. When it's active, when it's normal, when it's illegal, open too long, when it's failed. For example, if the door's open too long, I want to sound a buzzer at the door, a siren, or in the advanced settings. This setting shows me on an input, I can bounce an input. You have sometimes you have contacts that are very noisy. Then you say, no, this input must be active for say 100 milliseconds, and only then am I taking it as being active. Also, there's a setting, if you want to, for too long. If this input is in that mode too long, I will get a new status on this input. I would say that input is now too long. When do I monitor this input? When do I monitor it for active? When do I monitor it for normal? When do I monitor legal, too long and failed? And again, defaults are 0. I'm always monitoring this input for all these conditions. But I could say, for example, during the day, I don't want to know when the door closes. I only want to know when it opens. Again, these are advanced settings. I can have inputs as normal, so 0 is normal, that's the default, or I can say, no, this is a counting input. And when the count, so it counts up, and after a certain timeout, it then reports what the new count is. This is for inputs that change a lot. Example, you might have a turnstile that throws a lot of data at you, people just walking through. And as not to bottle up the whole section, it just every 5 seconds it'll tell you what is its count now. Outputs. Again, older controllers, we had specific hardware that we could expand the hardware, the number of outputs. Again, same as inputs, I can have an input name and I can go and edit it. Again, where is this thing connected to? Where is it sitting on my board? Or is it sitting on another board? And where is it sitting on that board? These are actually very simple settings. The defaults are all on-board local, so don't worry about it. More details in the advanced presentations. Here I'm setting what kind of output is this. Again, I would scroll through latch, I would scroll through buzzer, I would scroll through which one of them is it. It's latch number 1 or it's latch number 2. That's the reference type. And again, polarity. If I put a 1 there in that second digit, I will invert this. So normally open would become normally closed. This output can be that it's only controlled when an enabling input is active, and only when a controlling input is active. So for example, I could say I can control this output only if the key switch is in this position. Or I can say I can only enable this if an output is in a certain position. Only when the lights are on can I switch the pool off, for example. I can say this input will only work if another output is in a certain state. So again, advanced options, and don't worry about this. This is just to whet your appetite. Then there are time settings. I can say pulse. I can pulse, for example. The setting here is, remember, I'm busy with output number 1. That is my latch. I'm saying this latch is active for 2 seconds. I could say pulse it. So I could say go tick, 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 tick. So pulse this latch. For sirens having to make a wobbly noise or something, you might want to pulse them. So there's a pulse setting. You're probably never going to use this. The latch setting, yeah, something that you might change. This is how long the latch is going to be on. And again, notice the Caret command, the little upside down little arrow. So I would scroll through seconds, milliseconds, minutes. These settings are when something happens. I can say I am controlling this automatically. For example, I could say open the front gate from 8 o'clock till 9 o'clock in the morning. That's when everybody comes in. There's a guard standing there, so automatically control when is it auto active. So the first settings there are which time group for when is this active. I can also say when my changes be made. I could say maybe over the weekend I cannot change this output. So this is an overriding function that I cannot control it then. I can also say when must I report that something has changed? When must I say that the latch was controlled? I could say only report over weekends and not during the day, for example. Then there are vending options. I'm not going to go into them. That's all explained in the vending presentation. The Handheld also has a variety of utilities to help you test your installation, help you fault find. Things like show me the reader being badged, test the LAN, etc. This is available as a separate presentation, also available in the booklet. As indicated earlier, there's a program SS controller that runs on the PC that connects with a second socket to a controller. You can see the settings in the controller and you can change them or load them from files. There is a presentation that shows you how SS controller functions. This is the final slide of the installation presentation. It is just to show you all the tools that are available to help you with your installation. Firstly, on a reader, there are LEDs that will show you badge good, badge bad, door open. There are onboard LEDs. As you know, the new controller's got 10 LEDs. It shows you the communication status. It shows you the readers are active, shows you comms. There are plug-in modules. Now these little modules you plug in directly onto the connector. So some of them you can put in series. For example, on the reader, you could see the lights at the reader and on the outputs. Or you flip the little switch, so just unplug your connector, plug this in, and you can test your installation. These little modules are available from Softcon. Then we have modules, more modules that you can plug in, wire them up into a panel for testing on your bench. All these are available from Softcon. Thank you.